Hello everybody. I want to talk about the OpenFOAM in the following series. So you might be interested in using CFD in your daily work or for some like special work. So I have been an engineer for many years and also doing some academic research. Actually, my degree is really about the thermal fluid, but in the later engineering career, I used mostly use CAD and also finite element analysis for the product design, mainly for structural. But I recently picked up the thermal fluid flow, and I found compared to most of the open source or commercial software packages, OpenFOAM is really very developed and compared to my very initial understanding, now it can run in both Windows system, not the traditional Linux, and it has the PowerView as a strong backup of the post-processing. So that's really helpful. And for me, because I haven't used it for a long time, so it's really a starting point for me. And after using it or researching on it for like 2 months or half or 3 months, I can't remember. I think it has been a lot of information for us to work on, but some information may not so good, and especially for the beginners, and also for advanced topic here, for example, for the conjugate heat transfer. So that's topic for my first first talk is conjugate heat transfer CHT from scratch. For engineers or beginners, I think the difficult starting point is to understand the settings by using a simple example. And actually, I found one for you. So I think it is the best ever example because it covers the fluids, so two fluids regions, and also a solid heat transfer, and also the coupled fluid flow and the heat transfer between the solid with the between solid and fluid, and also the fluid itself. So let's quick look at the problem definition. So look at this. So it is very simple geometry. So we have 3 layers of material, so different materials. The outside 2 are the air and water, which are fluid domain, and separated by a aluminum layer which is 2 millimeters thick, and it's very similar to some industrial background. For example, in the heating, ventilation, air conditioning, so we have some air handling units. So the air is flowing through, and cold water is here or hot water here. We need to cool the water, cool the air, or heat the air by using water. Of course, we have the heat exchanger or heat transferring medium by using some solid materials. Here we use aluminum. And also, as I mentioned, it can be heat exchanger for some processing equipment. For example, in the chemical engineering, oil and gas refinery, we basically need to use air or water between two fluids to transfer the heat. And also, it can be the recent electronics cooling, for example, for data centers, for the electronic or high power electronics. Now we not only use air as a core medium, we also introducing the fluid, for example, the cold plate, to cool the air or cool the electronic parts directly. So in general, we have 2 fluid categories. We want the heat transfer happening among solids and two fluid regions. And if I give some initial conditions, for example, the geometry here, and also the inlet condition of the air, which is a hot air with 200 degrees C, and also 0.1 meter per second, and we want to cool it down by using cold water. So the cold water has an inlet temperature of 20 degrees, and compared to air, it flows slowly, so with 0.05 meter per second. So how can we use OpenFOAM to check how much temperature can be achieved by using this cooling medium, and what is the outlet temperature of the cold water? So that's very basic problem description.